In example 3, we are looking at whether something is a function or not. The definition again of a function is a rule that establishes a relationship between two quantities called the input and the output. For each input, there is exactly one output. So when we look at letter A, we're looking at our domain, our x values, and we want to make sure that they go to exactly one output. If you look right here at number 3, it has an output of 8, and the number 3 has an output of 4. Therefore, since the 3 has two different outputs, it is not a function. So we can say the answer here is no, because the input 3 has more than one output. If we take a look at letter B, each domain, each x value, each input, has exactly one output. None of these numbers go to more than one output. So we can say here that our answer is yes, because every input has exactly one output. If we take a look here at letter C, this is where we have what we call a mapping. And with our mapping, we have our inputs 1, 2, and 3. 1 goes to the output 8, 2 goes to the output 4, and 3 goes to the output 8. So they each go to their own output. It does not matter that these two go to the same output. It just matters that each one of these goes to just one output. So here we would say yes, because every input has exactly one output. The last thing that we will look at is going to be a graph. Our inputs are our x values, so those are along the x-axis. As we travel along the x-axis, we get to -4, -3, -2. We see that the x value of -1 has 1 point, or one output. As we travel along, we get to the point 1. The x-coordinate of 1 has two different outputs, two different y values, two different points. Therefore, this is not a function. So we will say the answer to this is no, because the input 1 has more than one output.